Rather than sampling, say, 100 across a school district or a high school, I divided it into males and females and sample 50 males and sample 50 females. There are a lot of advantages in doing that. If we were, for example, pollster, depending upon what we are interested in, we might divide areas into urban areas, suburban areas, and rural areas, because they will have different characteristics, either in their political preferences or maybe in some sociological characteristics. And so it's sometimes helpful to take that into account when you sample. So rather than sampling randomly across the entire population, you break it into strata, and then you do random sampling within a given strata, and then roll up your information about the entire population, making note of the differences between your strata. So that's an example of stratified sampling. Cluster sampling. Let's go back to high schools. The other class told me there were about 500 classes or high schools in Oregon. Let's assume that's the case. So I've got seniors, say, across 500 high schools. Now, suppose you're a researcher, or maybe you're the State Department of Education or something, and you want to assess something about seniors in high school. Think about what their plans are. One way of doing that would be the following. So, fix this. What are high school seniors planning to do, say, after graduation? Are they going to take classes? Are they going to go to college, community college, or are they going to work and join one of the services? All right, so I have let's assume 500 high schools. So I've got all these high schools all around the state. It's hard to get to 500 high schools, even by mail. Because if you send something to a high school via the mail, who do you send it to? Principal? Principals probably get zillions, even today, they probably get tons of mail. Now probably most of it comes in email, but the fact of the matter is people get tons of mail, email, what have you, and it's pretty hard to make sure someone actually gets it and they actually pay attention. So what you could do is the following. I can't really randomly sample across all 500 high schools or across all high school seniors. So what I might want to do is I might want to break it, just sample, say, 10 high schools selected at random, or maybe 20, let's say 20. So select 20, say, at random, and survey all high school seniors in those high schools. This is what's called a cluster sample. You're making use of the fact they're close by. They're all in some, generally speaking, geographic location. And that might be a little better because contacting 20 high schools would be a lot easier than trying to sample across all seniors across Oregon. I mean, you just get lost in all the noise. It's conceivable you could actually call up and actually get to the principal in 20 high schools, especially if you're the State Department of Education. I take several phone calls, but you couldn't have to do that. And so people will in fact use cluster sampling. Actually, the Census Bureau does the same thing. In between the censuses at 10-year intervals, they actually do collect data in the interim. And what they do is they often, they have several levels, and there's let's see, I've forgotten the name of the term. There is kind of a unit of organization, a census tract, I think that's the term. And a census tract, they're probably suburban, urban, and rural tracts. And what they will sometimes do is they'll just randomly select tracts, all right? And then, okay, they'll go into those tracts and maybe talk to everyone. Okay, that would be another example of a cluster sampling. It's a way of taking advantage of things that are geographically close together. Now, actually, the census will often use something in addition to all this systematic sampling. So what they may do is, at one level, they may select tracts, census tracts by strata, that is urban, suburban, and rural. And then within those strata, so they'll have a certain number of tracts within each strata, and then in the tracts, rather than talking to everyone, which can be time-consuming and can be expensive, what they'll do is they'll do systematic sampling. So in these census tracts, they have a list of all houses or residences in that tract. I think the number 200 comes to mind, and I'm not sure, maybe 500. What you might want to do is you would divide, say you want to talk to maybe 25, let's see, suppose you have 500 households, so suppose you want to talk to 20 households among the 500. You're going to go and ask them about, are you employed, how much are you working every week, and so forth. A lot of these places you may have to go back several times, either by mail or by phone or by something, because you won't find anyone there. Rather than do that across 10 households than across all, or 20 households, rather than do that rather than across all 500. So what you would do in that case, or one way of addressing this problem, is you select, again, assuming you have 500 households, you select the first household between 1 and 25 at random, and then every 25th every 25th household after that in your long list. So you select the first one at random, and then every 25th on your list go and talk to them. All right, that's an example of systematic sampling. Another example is in manufacturing. When you're manufacturing something, what you want to do is you want to do some quality control. So you pick items that are manufactured, and typically you don't test everything. That would be too time-consuming. Some testing is destructive, so that you take it out, and you're going to do something to it, and you can't use it after that, so you don't want to test everything in that case. So you might pick every 100th item, maybe every 50th item, it depends upon what we're talking about, and test that, all right, as a way of kind of gauging how well your manufacturing is doing. So cluster has to do with geographic location. Systematic is every item that's sampled. And you can often use a combination of these strategies, which are referred to as multi-stage sampling. So you might break your population into strata, and break it in the strata into, for example, in the case of censuses, or a census tract. So you pick a census tract, which they're geographically related, and then do systematic sampling within the tract. a simple random sample is simple in theory, but very complicated in practice to carry out. This is where statisticians make their money, is devising all these strategies. Again, as a way of trying to get something close to this here, but not at the expense or maybe the difficulty of doing it by simply randomly selecting across an entire population. Okay. We'll talk about some terms. Sampling frame is basically a list by which you select your sample. The reason you sometimes distinguish between the sampling frame and the population itself is they're not necessarily identical. For example, a list of registered voters in a district would be a sampling frame, but that's not the same thing as the population of individuals who are going to vote. It's not even the population of individuals who are registered, because registration lists are often out of date, and so there can be a difference between how you're doing your sampling and the actual population, and as a way of distinguishing it, we sometimes refer to the sampling frame as kind of the list, if you will, by which we're going to do the sampling, even though that we know in advance the sampling is not exactly the same as the population. Sampling variability. Even if you do a poll perfectly, and you have another poll to do the same poll, they're not going to get the same results. There's variability in polls, and that has to do with the nature of the random selection. We can understand the variability in that selection and can account for that. You get the variability because you're talking to a sample, you're not talking to everyone. You're talking to a sample because that's easy, it's convenient, and it's reasonable. You can't talk to everyone. It's either impossible or impossible, either time-wise, cost-wise, or some other way. So sampling always has variability. We've talked about undercoverage bias. If we contact people by phone during the day, we're going to miss people who are working during the day. If we contact people at night, we'll contact people who are at home at night, but not people who are working at night. The individuals in those populations or those strata may be different from the larger population in some important way. Non-response bias. You go home today, and you get a phone call, and someone says, I'm with so-and-so, I'm doing a poll. And you say, I've had enough statistics for one day. That's non-response. The people that don't respond, if you will, are going to be different than the people that do. This is what pollsters are up against, all right, is they try and find some way of making sure you don't hang up the phone right away. And if you do, somehow they can account for it. Now, what has happened over time, it used to be maybe about 34 years ago, if you got a phone call from a pollster, you were less likely to have the phone hung up on you. And that's because today we get phone calls from everyone. In fact, actually it used to be worse about 20 years ago when in telemarketing. You could just almost pick up your phone and put it down, pick it up, and you wouldn't miss any important phone calls for days. So our culture changes over time, and so the pollsters have a task to try and find ways around all these potential biases. We've talked about sampling with replacement and sampling without replacement. If the population is large enough, and then our sample size is small, usually less than 10%, it doesn't matter. The mathematics are, even though there's slight differences, we never use that in fact in practice. Sampling with replacement is sampling from a population, noting it, putting it back, shuffling it up, and drawing out a second time, thereby potentially drawing the same individual or item twice. Whereas sampling without replacement, you mix things up, draw someone out, you note it, and you leave it out before you sample again. Okay? So there are differences in these ideas, but in practice, we often ignore them. Surveys with limited validity, voluntary response surveys. It used to be, and I haven't seen this recently, but some of the local broadcasters would pose a question during their newscasts, and you were supposed to call a certain number if you felt some way, and then you were supposed to call another number in another way. That's what's called a voluntary survey. And what basically is only people who are motivated to call whose opinion is then registered. That's not the same thing necessarily as a random, or necessarily the responses that would be obtained from an entire population. Now, why would a television company want you to call up and register your opinion on it?
Marketing.
Well, how would it help their marketing?
I don't know.
You're right. It may seem like they want your opinion. Actually, what they want to do is they want your phone number. So if they have caller ID, they can identify where you called from and use that as marketing information when they want to sell ads. Okay? Sorry. They like your opinion, but more importantly, they like your dollars. Okay, so a lot of voluntary surveys, the purpose is really to try and identify who's responding and using that for marketing information. Not a bad idea, it's just that be aware of that fact. Convenience samples. I haven't seen this so much recently, partly because I don't go to shopping centers that often, but it used to be when you went to a shopping center on the way out, someone might say, would you fill out this form for me? All right, now, they probably still do it. I don't know if it's done commonly. Now what they want to do is they want you to carry these RFIDs so that when you walk into the store, they can present you with an ad that's tailor-made for all your past purchases on Amazon, eBay, and all these, and Google searches, and so forth and so on. Remember, it's only about extracting money out of your wallet. So when you go into the store, make sure you have your hand on your wallet, because they're trying to get it out. All right. Convenience sample is samples that are taken out of convenience. So people walking out of shopping centers are often worried about, or used to be, or if you stand in a corner, every now and then you can see this, someone's down the corner, they're taking a survey, be a little careful. They probably have other motivations other than trying to find your opinion. But convenience samples don't correspond to reality because they're only selecting in certain locations. And it's out of convenience, not out of any kind of scientific method. There are other ways of finding out information about groups, focus groups. I think they still use that. A couple years ago, I don't know, I was called, this was probably about 15, maybe 20 years ago. I don't know, I was called and I was part of a focus group, and I don't even remember what it was. They bring in that it's a more dynamic conversation. And the intent is the same. They want to find out something about their customers. You do polls, by phone, by mail. That's one way. Today it's more about mining or keeping track of your online purchases. But focus groups are also a way of determining information, probably a little more flexible. Today also, there are markets out there where you can bet on the outcome of an election. And some people propose these as a better way of identifying who is likely to win an election. Making a wage on an election is illegal, I think. In Britain, you can actually bet on the outcome of an election, but not in the United States. And I know in Iowa, there's the political scientists who do this. I don't remember how successful they were in 2012. Basically, they have a market, and you bet who's going to win, and you put some money down, and then if you win, you get, your money. There's a certain odds you win that. And the thing here is that the intent here is somehow that the market somehow has information, and you bet not on what your preference is, but on what you think the roll-up of information that you have is going to indicate who's going to win. It's not a bad idea, but markets have their problems, as we have all discovered, especially the stock market. Okay. Do they serve a public purpose? Who knows? Should poll results drive public policy? Only when they agree with me. Does the fascination in polling distract us? You betcha. All right. I threw that in a couple years ago. I should probably throw that out. I'm letting my cynicism show through. All right. Now, Chapter 13 is mostly about experiments, but we're going to talk about what are called observational studies. And actually a survey, a sample survey, is an observational study. Okay? What's the difference between an observational study and an experiment? An experiment, you do something to someone. You impose a treatment, and you look at the response. In an observational study, you're only interested in collecting information. You don't want to change anything. Okay, now, types of observational studies, that is, no changes imposed, sample surveys, which we just considered. They're also something called a retrospective study, and there's something called a prospective study. Let's talk about this one first. The other day, last Sunday I think it was, on the news program 60 Minutes, they interviewed a researcher who was looking at the residents of Leisureland in Southern California. And this is what they did. This is from the website of let's see, University of California, Irvine, and it's probably associated with maybe their medical college there. And they interviewed, this was on 60 Minutes, so I went to the website. Basically, there's a place in Southern California called Leisure World. It's a large community, a retirement community in Orange County. Is Orange County part of LA or? Yeah, okay.
It's not. It's near.
Oh, it's west or east of LA.
South.
South. Oh, okay, south. All right. So what they did is it's called the Leisure World Cohort Study. This is a prospective study, and what they did is, starting in 1981, they took a snapshot of everyone who was living there. Apparently, they sent out surveys. And they asked them a whole bunch of questions about their health status, their eating or behavior, alcohol consumption, drinking, all that sort of stuff. And what they've done is they've taken that snapshot and they've watched these individuals over time. There are actually a number of studies like this, but this is one that was in the news. And what they try and do is they record this information. They're not trying to change it. They're just saying what is connected to what. Okay, what are the associations potentially between various characteristics of these individuals and their health status? Now, I want to emphasize that in observational studies suggest things, they do not prove things. And we'll talk about that a little bit more. So in reading down this list, be advised, these are associations, but they are not necessarily causation. Here's the, now this is from their website. These would have been published in journal articles, and this is a summary of those journal articles. People who drank moderate amounts of alcohol or coffee lived longer than those who abstained. Now hold on, don't rush out the drink. It may not be the case that drinking is the thing that in fact, makes you live longer. We're going to talk about this. But anyway, it looks as though people who drank moderate amounts of alcohol and coffee live longer than those who abstain. Obviously, those who overdo it are probably not going to get to 90. Okay. It's kind of a self-limiting thing. People who are overweight in their 70s live longer than normal or underweight people. So I'm not in my 70s. Not yet. Over 40% of people aged 90 and older suffer from dementia, while almost 80% are disabled. Both are more common in women than men. So that, okay, another result. About half of people with dementia over age 90 do not have sufficient neuropathology. That is, there's no evidence in their MRI scans or in the autopsies that are, performed after they die. They do not have sufficient neuropathology in their brain to explain their cognitive loss. See, for a long time, and it still may be the case, things are always complicated. Alzheimer's has been associated with a plaque buildup in the brain, okay? But it could be that, first of all, there are different forms of dementia, all right? And so that would suggest there are some forms of dementia that do not have identifiable, at least at this point, neuropathology that says, oh, you've got this, now you're getting stupid. Oh, thank you. All right, so anyway, this is an observational study. It's a prospective study, so they took a snapshot and they looked at them forward. Now, let's take a look at one of these relationships and see why there may be more to the story than is first presented. Now, if the researchers are here, they might be able to counter my assertions. I'm tossing this out as a way of analyzing observational studies. So here what we have is we have moderate drinking, and then we have longer lifespans. And I'm going to draw a dotted line here that indicate that they are associated. That is, it seems as though people who identify themselves as being moderate drinkers have longer lifespans than those who don't have that characteristic, or do not identify in that way. Now the question here is the following. Does this cause that? No observational study can ever prove that. It suggests that that may be happening. Now why might that be the case? Well, there may be some things in alcohol that maybe have positive health consequences, which cause you to live longer. All right, that's a possibility. There was a study not too many years ago which said that drinking red wine reduced your risk of heart disease. And everyone went out and started drinking red wine. I don't know if that's been confirmed by other studies or not, but that's what observational studies often do. They'll say, oh, these things are connected or associated, and people falsely assume, all right, that one is causing the other. Now, they may be. It's just that the study itself does not prove that. So what I'm going to do here, let's write this as an association. So the association is correct here. I don't doubt the results. The question here is, does it cause? Is there a causal relation? That we don't know, at least based on the evidence we presented here, based on observational studies. Now, let's consider another possibility. Let's call this self-control. Now, this is an invented factor, if you will, for purposes of illustration. I don't know how you would necessarily determine whether or not someone exhibits self-control. But this is what might be happening. Again, this is just to toss out the complications involved in interpreting observational studies. Again, the dotted lines means there's an association, and the solid lines means there's a causal connection. All these causal connections have a question mark above them because nothing I have given you here or they have given you here says there's a causal connection. And this is only primarily for purposes of illustration, but it may also be that big thing related to reality. What is self-control? Why might that help you? And why might this be maybe the driving factor? Maybe it's self-control, self-moderation that causes us to drink moderately, which not only causes us to live longer, but the self-control also helps us make better choices across all choices. Nutritional choices, exercise choices, sleeping, all that sort of stuff. Again, I don't know how you would ever measure this. You might ask them directly in some sort of form. So it could be that the real driving thing behind something like this is another factor which is yet unidentified. So it could be the individuals that live longer, in fact, are the ones who have more self-control or self-discipline, and they tend to moderate their behavior. They tend to do things that are, I mean, they're willing to eat healthy foods, but every now and then for purposes of celebration, maybe not every day, they're willing to eat maybe things that are otherwise nutritionally not desirable, maybe high-fat foods, sugars, what have you. So maybe it's self-control, self-moderation that may be driving the longer lifespans, not so much the moderate drinking. Again, I have no idea whether this is correct. There could be something in alcohol or in wines.
Yeah, I pulled it up actually through the Mayo Clinic. It is supported.
I'm sorry,
Yeah, it is supported that it is good in moderation.
in moderation, yeah,
Yeah,
okay.
women can have one a day and men can have two because men eat way more
Right.
and they produce an enzyme.
Oh, right, I can have 2 a day, huh?
Right, but is it the actual wine, or is it the fact that wine makes you less stressed?
Well, this is, first of all, all I'm trying to do is illustrate the complexity of observational studies.
Right.
What happens in observational studies, usually if you have multiple things, they may all point to the same thing, that moderate drinking is good for your health. I suspect, just what I've read, that's probably the case. But just to illustrate how something may be lurking in the background, this is what we call a confounding factor. It's kind of mixed with everything else. So let me put that down. So we have that term. Confounding factor, it's mixed in with everything else. I'll give you another example in a moment. Self-control is a little probably hard to measure, okay? I mean, you can ask questions about their behaviors, but, and I'm not saying you couldn't do it, it may be a little harder, or as you ask people, how much do you drink a day? 0 glasses, 1 to 2, 2 to 3, and then the people that are 5 and above or 10 above are not going to make it to 90, okay? We're going to have too many health consequences Unless, however, you are Winston Churchill. Anyone know who Winston Churchill
Yeah.
is? He was the Prime Minister of Great Britain during World War II. And when he died, I don't think they needed to preserve him. He had enough alcohol in his blood, and he lived to, I don't know, the late 80s, 90s, I don't know, something like that. So if you're Winston Churchill, this doesn't apply. He could apparently, well, he might have lived longer, even more modern.
Another interesting thing is if you're Asian, you get drunker faster, so that could
Oh, is that right?
Yeah.
Okay.
Because they like
Now, you see, this is what a researcher or someone who's interested in this would ask. Are the people in leisure world different,
Yeah.
maybe, than people that live other places? And that's always a question. How are these people representative of the entire population? Okay? Again, this is suggesting, and by itself does not prove. Now, if you have multiple studies all indicating the same, then the weight of evidence, it says that there's more likely to be a causal connection. So this self-control, this factor I've just entered for purposes of illustration, is a confounding factor. And this is something that researchers are always trying to do, is what are the confounding factors, the things that are getting mixed up here, but I haven't clearly separated out to see how much of this is due to this, how much of this is due to that, and are these two connected? That's where the researchers make their money, is trying to figure out and sort out that information. Okay. All right. So, let's see here. All right. So we will look at a prospective study here. This example, you take a snapshot and follow them forward. A retrospective study takes a snapshot of a given moment and asks them questions about the past, and they don't follow them after that. So, for example, if I were to be surveyed about my current health status and then asked about my exercise and nutritional behavior in the past, that would be a retrospective study, assuming I'm never worried about my health status after that. In a retrospective study, part of the challenge is you're asking people to remember what happened in the past, which they may not have a full, may not fully know themselves, or they may shade it a little bit. So retrospective studies have some issues as well. Prospective studies have issues as well. This is one. What's the difference? Is the association, is it causal or is it something else? Okay, so when you have one of these studies here, you ask, does the data suggest any relationships? That's obviously one, between the variables or the conclusions. Experimental studies of changes imposed. This is typically what's done in medical experimentation, sometimes with humans and sometimes with animals. I'll get an example in just a moment. A well-designed and conducted experiment allows causal conclusions to be inferred. It's experimental studies that are considered the gold standard in statistics. We know, we can conduct experiments in principle, and we can find out what causes what. In the case of moderate drinking, well, generally you can't, do an experiment like that with humans. It's too complicated, and you could probably do something with rats, something like that. It might provide supporting conclusions, but experiments allows this kind of real, a far greater certainty about what is causing what, okay, as opposed to what may be causing what that you observe in an observational study. Observational studies may suggest, but experimental studies prove. Or at least to the extent that anything is proved. A simple observational study, units are selected at random from a population. A measurement is made on the units or the items selected. The sample mean and the sample standard deviation are computed. For example, we're measuring something. There could be other things that we measure. And then what we do is we make claims or inferences about the entire population. In 244 especially, we're doing from the sample mean and the sample standard deviation, we'll come up with what are called confidence interval, and actually that's what you're getting in a popular or a poll study. You get the center and then the margin of error. That's basically a confidence interval. And then we can also do tested hypotheses. Again, these are topics that come later in class. So in an observational study, this is the basic outline of a very simple one. Let's talk about experiments. Now, there are lots of different types of experiments. In fact, I'll get to several here. We might, for example, we might be doing an experimental study, or excuse me, a study in medicine, and we have what are called experimental units. As our people, we call them volunteers or subjects. We don't call them experimental units. People object to that term. They think they're going to be put on the table and dissected. Experimental units, subjects, volunteers, are randomly assigned to one or two groups. This is a very typical experiment in simplified form. One group receives the treatment, whatever that may be. It may be in medicine, it may be a medical procedure. The other does not. The treatment is thought of as the explanatory variable. Then what we do is a response variable is observed for all the units in both the, what we call the experimental group, those who got the treatment, and the other group, which is called the control group. We look at the difference in the response variable. And if we see a significant difference, say between the mean value of each group's response variable, that implies the treatment was the cause of the difference. So if you've got, say, a new drug that's going to reduce your cholesterol, you bring in people who have maybe elevated cholesterol, you randomly assign them to two groups. You give one group the new medicine, you give the other group a sugar pill. We often give them a sugar pill so as to kind of make them think they're getting something valuable. And then they come back several weeks later, maybe a couple of months later, and they measure how much cholesterol they have in the blood. If the people taking the medicine, so to speak, have a reduced cholesterol level, then what we do is we say the treatment was in fact the cause of that decline. In simplified form, that's what a lot of experiments are. Okay, let's see what time it is. Now, as I've explained before, a retrospective study, participants are questioned regarding their diet, exercise, and current health. And then we ask the question, is the current poor health, or maybe current health, suggested by any identifiable diet or exercise data? So we snapshot the current and then look back. Okay? Prospective, we snapshot at a given moment and watch them into the future. And we'll take a look at a few examples, more examples in just a moment. Now, complex experiments can have the following forms. This is an inventive experiment, so I think it's fairly reasonable. Suppose we have a large lecture class at a university, and we want to know whether Gatorade is Gatorade spelled with an E? It is. Whether or not Gatorade in a pep talk, say, improves scores. So, do these improve, say, test scores? I can argue why this might be the case. What I'm going to do is I'm going to create a diagram here. Columns represent yes. And then the rows will be associated with how much Gatorade. I think Gatorade is probably just one word. So they could have just, they could get no Gatorade, another group might get 1 cup, and another group might get 2 cups. So this is what we do. We have a large lecture class, and we pick people at random and put them in each one of these, what we call treatments. So some individuals in this class will get no pep talk, say, before the class, and they won't get any Gatorade. All right? Some people will get 1 cup of Gatorade, but no pep talk. So what I have here are 2 factors. One factor is Gatorade, and the other one is the pep talk. So the factors are Gatorade. Actually, I should probably use energy drinks. That's a more common. People are still using that stuff. I mean, things come into fashion and go out of fashion, and I'm so out of fashion. It's like,
Is this kind of like the placebo effect?
oh, we'll talk about that, but not necessarily. Yes.
Sorry, can you say that the Gatorade
Well, okay. The treatment is when we impose something, we think of that treatment as being associated with the explanatory variable, and what we measure as a constant is the response variable. Now, remember in statistics, we don't normally use independent variable and dependent variable. Those are terms in math. Independent variable is often associated with the letter X, but we don't use independent in statistics because independence has a slightly different meaning than independence in math. Okay, so we're going to get to that when we talk about probability. Okay, so we have Gatorade, and then we have a pep talk. The Gatorade, there are 3 levels. You either get none, you get a cup, or you get 2 cups. There are 2 levels of pep talks. You either get a pep talk or not. Now, why would one do an experiment like this? Well, you could submit or replace this with some sort of energy drink. Right, that would be a reasonable experiment as well. When you go into a class, your attentiveness is going to be determined by a lot of things. It could be that maybe Gatorade gives you more electrolytes. I think that's what it does. It may help you improve your attention in the class. It is also the case that pep talk will influence, in fact, how people perform on various tests. If you take people and say, you can do well on this, and maybe have a general positive, upbeat message, that in fact will be translated often into measurable results. So here what I'm doing is I have 2 factors. One is whether or not you get some sort of drink here identified as Gatorade, and whether or not you get a pep talk. Now there are a total of 6 treatments. See, I've got 2 levels of the pep talk, either you get it or not. I have 3 levels of the Gatorade, so I have a total of 6 treatments. Okay, now, so I've got 2 factors. That's what I mean by multiple factors. Each factor can have 2 or more levels. Gatorade has 3, pep talk has 2. Talk about blocks in a moment. Now, I take this great big class and I randomly assign them to one of these 6 treatments. We measure their test scores at the end of the quarter or whenever, and then we take that data and try and associate that with whether or not they got Gatorade or not, and if so, how much, and whether or not they got a pep talk. In an experiment like this, you can look at the interaction between pep talks and Gatorade. All right, both of them may help improve your scores. Now, someone might come along and say, "Wait a minute, you did this experiment for a class in the morning. Classes in the morning are different than classes in the evening or in the afternoon." So what we would do is, in blocking, what we do is we repeat the same basic experiment in the morning for a morning class, maybe an afternoon class, and then maybe for an evening. So this is morning, afternoon, and then evening. Why would we do that? Because it could be that what happens in the morning is we're not going to get the same sorts of results that we would in the afternoon, and the same thing is true of the evening. They may all be different. All right. Instead of using Gatorade, we could try an experiment with energy drinks. But basically, these are factors over which we have control. In some sense, we don't have control over this. From morning classes, afternoon classes, and evening classes. Those are part of the fabric of education. We have to deal with that. But these factors, two factors, may have different influences on these different time periods. So in really complex experiments, we have factors, blocks, and then, not only might we measure their scores, we might measure their attitude towards the class. So we could measure multiple things across, let's see, we've got 6 treatments in every block. We have potentially 3 blocks. So that would be a total of 18 treatments, if you will, if we include blocks. And then we might have multiple measurements in a given treatment. So that's how complex experiments can be. And in fact, again, this is where statisticians make their money. And I went to undergraduate school at Iowa State University, and you probably are aware they grow things in Iowa. There's a lot of agricultural statistics there, and you can have similar sorts of very complex things in agriculture. You have fertilizers, pesticides, herbicides, for those who are organic. And then you can have lots. Different parts of Iowa will have different soil characteristics, they'll have different climate characteristics. You can't do anything about that. So you might have multiple factors and then replicate it across all your different sites in Iowa as trying to sort out what's going on. Okay. If we could do an organic experiment, so you might do an experiment across multiple blocks where you look at organic fertilizer, and then you could use non-lethal pesticide or insect or weed control. There are various techniques. There are different ways of cultivating soils, all sorts of stuff. So all those might be considered in trying to figure out what is causing what and what improves the yield. Or sometimes the downside of improving the yield is the nutritional quality may go down. So you may want to measure the nutritional quality as well as the yield, that is the amount of bushels of corn per acre or whatever. So experiments can be quite complex. Principles, let's see, I think what we'll do is we'll do these last 2 slides and we'll take a break. Principles of experimental design. Compare. And that's when you have 2 things. The experimental group or the treatment group and the control group. So, this is the control group. Nothing happens to them. You have the treatment group, they get something done to them. Okay? You want to compare things if you can. You want to keep things the same across all your treatments, other than the treatment itself. I would like all of these people to be uniformly distributed across the entire lecture class so that they don't all end up in one spot. thereby biasing the result maybe in some way because the lighting was either poor there or the auditory conditions were better or worse. You want to avoid that. You want to keep everything the same except the factors that you are actually imposing. You want to randomly assign individuals to these 6 groups, if you will. You don't want them allow people to select them. In other words, you want to see what are the causal factors. Replicate. You want lots of people in each one of these treatments because there's going to be variability. And you want to see what the average change is, not the change for one individual. It's hard enough. I mean, if we just had 6 people, there's anyone's guess as to what is causing what. We want replication in each one of these treatments. You block when necessary. That's what I refer to as the morning, afternoon, and evening classes. You don't have control over that, but you have to account for that. So you take the same basic experiment and do it in morning, afternoon, and evening. In manufacturing, you have often a day shift, evening shift, and evening shift. Those are different shifts. People at night usually have lower seniority. They tend to have less experience. They're going to have more challenges manufacturing. So if you impose some sort of experiment, you want to do it across all your shifts. The blocking is the shifts. You can't do anything about that. When you impose the experimental treatment on each one of the shifts and see, again, control for both the factor that's being imposed and the blocking that is just part of the background.
So when you do the experiment, you just do the random and you have to show the blocking here, certain like evening, morning, and you had just.
Okay, what I'm trying to say here is the following. What I've gone up is in complexity. Here is a case where I have 2 factors. The pep talk is a factor. It has 2 levels. You either get the pep talk or you don't. The Gatorade is a factor. You get either 0, 1, or 2 cups. 2 factors. Now, I could do this in a given class. But then someone might say, well, is it going to be different, say, in an afternoon class or an evening class? So if I do this same basic experiment across all these 4 different conditions that are always going to be there, I'm blocking. In other words, I'm doing the experiment across all the different blocks as a way of understanding what the blocks themselves are telling me. I mean, is our morning classes, afternoon classes, evening classes, are they going to respond differently to these factors? Maybe, maybe not.
So when you do the experiment, this one, you have to say morning class.
Oh. Well, if you only do it in the morning class, there are no blocks. Block is a term which accounts for the fact there are certain things an experimenter doesn't have control over, cannot change, but needs to account for in doing the experiment. So in a case like this, where you have morning, afternoon, and evening classes, that's just the background, that's already there. That alone might change the results. So you want to account for that or control for that, and you control that for that by doing the same basic experiment across all your different, what we call blocks. Okay? Control group. Usually the control group doesn't have anything done to them. Okay? They're the ones that we're comparing, they're kind of the baseline comparison. Blinding. Blinding is often used in medical experiments where neither the participants nor the medical personnel know who's getting what. If you're taking a medicine, whether you're in the treatment group or the control group, you're probably going to get something, a pill of some sort, if it's a medicine. The people in the treatment group get the real medicine. The people in the control group get what's called a placebo, which is often just a sugar pill. The intent here is the following. The very act of taking a pill from a medical professional is probably going to help improve your medical condition. What you want is by imposing, if you will, by giving both groups, the treatment group and the control group, the same looking thing, you will have controlled for the possible variations that may result if they knew what they were getting. So in blinding, what you're trying to do is you're trying to prevent, if you will, those who are being experimented on from knowing whether or not they're in the control group or the treatment group. Now, sometimes the medical practitioners themselves don't know who's being treated. In fact, I had a student in a class a couple of quarters ago who, in fact, was in charge of a giant nationwide experiment, and she was the only one who knew who was getting what. Someone has to know that, but the medical practitioners and the patients didn't know whether they were in the control group or the treatment group. So there's no bias that may result from knowledge of whether or not someone is in the treatment group or not, either by the patient themselves or by the medical practitioners. The hope is to remove that bias and then focus on what in fact is happening, if anything. Let's see, and we talked about placebos. So we don't call people experimental units, we call them subjects or participants. We've talked about confounding. Confounding has to do with the fact that you could have multiple things going on. This is true everywhere. All right, not just in this example here. There could be, for example, when they look at families, it's hard to differentiate between the genetic heritage and your behavioral heritage. Everyone that grows up in a family, I think that's most of us, 99.99999%, you have influences due to your genetics and you have influences due to your the family environment, behavioral aspects. Both of those are going to influence things, and sometimes it's hard to sort out what is causing what. There's a little town in Ohio called Twinsburg. And Twinsburg has a twins festival every year, and people who are twins often descend on Twinsburg to participate in this festival, and medical and behavioral and psych also descend on the same area to look at twins, because twins have basically the same genetic heritage.
Well, identical twins too.
Identical, yes, that's what I mean by identical, yeah.
Okay.
And actually identical twins don't have identical genetics either.
Yeah, but it's a lot more than your sibling.
Yeah, you and I have different genetics.
Yeah.
Obvious. You learned the darndest things in college, right? Did we go through the reason we use a decimal system is you have 10 fingers? That's what you go to college for. All right. Yeah, what they want in Twinsburg, what they do is they're controlling for genetic heritage, basically. Twins have basically the same genetics. So the difference they see have to do with environmental factors. And they used to do studies, they probably still do, of twins who are separated at birth.
Yeah.
Because not only, in that case, they have different genetic, or they have the same genetic heritage, but then what they do is they they are raised in different families. And the question then is, are we seeing differences? And then in that case, they're more likely to identify differences that have to do with genetics and differences that have to do with family environment.
So do they do that? I think they did that with identical twins because.
Yeah, it's not fraternal, it's identical twin. Yeah.
And it was like interesting.
Oh, it's fascinating, yeah. And basically, for many decades, the social scientists were in a great big war. Is it nurture or is it nature? Well, most of my guests have compromised and said yes to both. The people who were nature said it was genetics that influenced who we are. The people in the nature, nurture would say, it's our family environment determines who we are. I think most social scientists now would say, well, it looks like both. They kind of interact. Okay?
When was that shift changed? Like after the study or?
You have to go to your social science. I'm kind of aware of it from the pattern of what happens in the media. But my understanding is that social scientists have kind of come to a truce on this.
It's never been about which one, it's been about how much of which one.
Well, that's what it is now. Okay, in the past, it tended to be more one-sided. You were either the nature or the nurture part. But I think what is now is it's more of a kind of, which is more important maybe, you know, and in what condition. I mean, different, you know, and yeah.
And even then, there's the perspective of a person having their own individual experience affecting them too.
Oh, absolutely.
So,
And there's Jungians who say we are born with a, we select our parents.
what?
It's a fascinating idea.
I did.
Oh, you did? You have no memory of Judy. Yeah, Jungians are not terribly well known. They take a far more mystical approach to life. I heard a guy, and I thought it was a fascinating idea. He said, don't blame it on your parents. You picked them. And I think what he was trying to say, the thing that did for me is he said, this is a really interesting idea. I have no idea whether it's right or not. But he actually presented some data which seems to suggest it's not so far out as one would ordinarily think. Things happen, suck it up, get over it, get on with your life. That's my 30-second introduction to that subject. Matching. Sometimes what we do is the following. Suppose I have 10 volunteers and I want to know how well their driving skills are influenced by maybe ingestion of, say, coffee before they go out driving. This is what we could do. Take our 10 volunteers on a given day, all right, half of them randomly selected to give coffee, half of them don't. They drink their coffee, they go into the driving simulator, and they look at, you know, how well the two groups of drivers perform in a simulated environment. Next day they come back, 5 who got the coffee before don't get it now, and the 5 who didn't, they repeat the experiment. All right. So one day later, you switch sides, so to speak. Again, you measure your driving skills. This is what's called a matching. So you have one individual that is both part of the control at one point and part of the treatment. The thing is, everything else presumably is pretty much the same. And that was a very simplified example. People are going to drink coffee anyway or not drink coffee. Maybe it's Gatorade or something else. All right, maybe it's chewing bubble gum. I don't know. The point here is what you do is you use the same individuals for both the control and the treatment. And you alternate them. And then what you do is on an individual basis, you can then measure the difference. And what you've done is you've controlled for all the other factors that are going to influence driving skills.
So do they use this
Oh, yeah.
for weight loss? Like, it seems
Oh.
like they would do that.
Well, in weight loss,
Since it's a big-
first of all, the ability of experimenters to come up with experiments is extraordinary. So I wouldn't be surprised where you couldn't have some sort of matching experiment where part of it, you're part of the control and part of it, and then another part, you're part of the treatment. The problem with something like weight control has to do with, you know, you kind of, it'd have to be over a long period of time, I would think, because you wouldn't necessarily notice.
So this would be more short-term then?
Yeah, probably more short-term as well. Yeah, I think the author has some other examples and a better description of what I've given there. Okay, let's take a break, and when we come back, we'll start talking about probability. We'll get that started, and we will almost be be back on schedule, not really.